First of all, thanks for coming by and watching this live stream. And we are discussing here Thinking Particles 6.8, our latest release. And we are going to explore a little bit OpenVDB and how we can use OpenVDB functions to modify and change volumes, and also how we can create volumes. We are doing this with looking into the Boolean operations, which are very powerful and are a great tool, because when we do Boolean operations with OpenVDB, we can be sure it's a watertight result. It always works. There's no fancy or crazy things going on, because a volume always works with Boolean operations. However, there's some restrictions how you can create these volumes, so that depends how good your initial geometry is, but usually OpenVDB is amazingly robust. It can even use crappy meshes and create volumes out of that. So let's dive right into it, and let me bring up here this scene. And please feel free if you have questions, or if I'm going too fast, or if you want to suggest anything, let me know. I'll try to check the chat as often as I can. So we will just start with this scene here, and before we do the Thinking Particles part, let me show you what we have here in this scene. So in this scene we have multiple cylinders, a sphere, and a torus. Excuse me. What we want to achieve here is we want to bool out or subtract these cylinders from the sphere, and then we want to move this torus through this object. So we have multiple things going on here. So we have one Boolean operation that bools out the cylinders, and another one that's dynamic, where we want to move the torus through the object and bool out the things. Let me hide these objects again, and let's have a look what I was talking about. Let me just get this to a full screen display, and there you can see the visualization of the volume of our torus, and I'll just move the torus through the volume, cut through, and this object is repaired again. So that's what we want to achieve, or actually that's what we are achieving here in this scene, and we are going to have a look now how this is done with OpenVDB. Let me open up our Thinking Particles setup here, and let me get back to the view. So the first thing we can see here, we have these Boolean operations here and our torus, and when we move it, it just cuts through. As I said, we want to have it working, so it cuts through here. So how is this achieved? Let's have a look. The first thing is we have multiple dynamic sets. We have a create dynamic set, and we have the dynamic set which we named dynamic sets. This is a terrible name, so we would rather name it OpenVDB. And I always suggest keep your dynamic sets organized. It helps a lot, because when you're working on a complex scene, you will have a lot of dynamic sets. And we have seen dynamic sets, hundreds of them. There's several guys out there who do complex visual effects stuff. They have hundreds of dynamic sets and sub-dynamic sets. The only way to survive that is having order and proper naming convention. So I just named that, and we have another dynamic set we already named Boolean, so we know what's going on. But let's start with the create dynamic set. In the create dynamic set, we have multiple object to particle operators. What it does, you pick an object and it's taken into TP and transferred, and we get the information, the mesh, and all the information we want. So how do we get the mesh into? So we pick the sphere here, we get the mesh of the object we pick in 3D Studio Max by instancing the shape. So that's transferred into thinking particles, and then it becomes a particle with a shape on it. So, and we store that in our particle group target. Here we have the, up here we have the particle groups, target, operand, and pre-bool. So these are our three particle groups. This helps us to organize stuff and know where things go. Especially when we do very complex Boolean operations, it matters the order and where things go. Let's go here to the first object to particle. So we have the sphere, that's our main object we want to modify, the target. So I just called that target. You can call it whatever you want, but let's say that that's our target, or also it's a good habit to rename your operators when it gets really complex. So we can have object to particle sphere. So we know that's the sphere. And let's have a look at the next one. That's our cylinders we want to bool out of the sphere, as we can see up here. So let's do the same thing here. O2P, object to particle, cylinders. So we're cleaning up here first. So I'm just saying it's a good habit, because later, if this would be a very complex scene setup, you'll be thankful for naming your operators and dynamic sets properly. So let's have a look here. That's the torus. We can see that, and the torus goes into the operand. That's the one we want to push through the sphere. I would say same deal. Object to particle, torus, and here we go. And the only thing is different from the other object to particles is we give it a velocity, an initial velocity. So when the particle is born, the torus, we give it a velocity of 80 in the positive x direction. So that gives us the actual movement of this sphere. So the sphere is moving through the object here. So that's our create status. So we get all the objects in. We all store them properly in particle groups. So first step is done. We have transferred all our 3D objects into thinking particles, into our procedural visual effects tool. So now we can proceed to the next dynamic set. Now we want to use this information that's already sitting there and waiting for us, and we are going to use it now. So I'll open up the OpenVDB, and here we already start to get a little bit complicated, and we are doing some things I want to explain here. But like I did with my first getting started videos, the first thing you should always do when you're working with OpenVDB, create your OpenVDB container. This is a container node. This node doesn't do anything except organizing and holding the names of your volume grids. It doesn't create anything. It doesn't create a volume. It just tells the other operators, hey, we have space for a distance and a restore in this case. Let me explain what that means. So we have two volume grids we want to have in our scene setup. We want to have one distance, signed distance field of type level set, and we want to have another distance field we call, or I call, restore. So you can rename this anything you want, or you can add any more volume grids you want to create. But for this type we only need two signed distance fields. So I created these two distance fields, and that's actually all. So this operator is the container and tells us, okay, we want to eventually use these two volume grids. The next thing you should do, and this container, it doesn't matter where the container is, so you can place it in this dynamic set or anywhere in your dynamic sets. Because it's a container, it doesn't matter where it is. But I like to keep things organized, so I know OpenVDB stuff is right now in the OpenVDB dynamic set. So the first thing we want to do is, let me just go back so that you remember. We have these cylinders here. And these cylinders we want to bool out of the sphere. So the first thing we want to achieve is create the first Boolean operations. Bool out all the cylinders in one go. So let's do that. Let me bring back our setup. So this first set we are going to do is we need to turn the cylinders and the sphere into a volume representation, because OpenVDB is all about volumes. So what we are doing is we are scanning, analyzing the surface of our objects we brought in, the cylinders and the sphere. And then when we have scanned this, it is turned into a real volume representation. And then we have all the fun in the world. We can do Boolean operations and much, much more stuff. Really crazy stuff with volumes. And we can do that very efficient and fast thanks to OpenVDB. And it's fully multi-threaded in most of the operations you do on these volumes. Okay, so let's have a look. We want to turn our target into a volume. So we do that by using the shape to volume VDB that takes our particle group target, and we store in the distance grid or volume grid, we store the volume information. And that's our container where we take that. So we use the target, and when we remember, let's go back, who's the target? The target is our sphere. So the first thing we do is we transform or convert the mesh of a sphere into a volume. That is done with our first shape to volume VDB. So it takes the sphere and turns it into a distance field. And the distance field we have here as an output, that's our volume data. Now we can work with the volume data. But we are doing here something interesting. We have two initiators, and if you're a thinkingParticles user, you know you can't have initiators in parallel. An initiator is calling all the connections, so that we indicate that with these little asterisks. So this is an initiator, so it calls all the connected operators behind them. So, but we have another one here, shape to volume, that is our pre-bool, that's our cylinders. So how do we do that? What we do is we abuse, so to say, the initial particle that is the output. Okay, this is the first volume particle, and this one is activating the shape to volume when this is called. So when our sphere is done and we get the distance field, that's the initial particle output, we call the cylinders, and we have 3 cylinders. So now this thing is outputting 3 times its Boolean operation with this information. So we have all the cylinders in here in the pre-bool group. Let's verify that I'm telling the truth. So all the cylinders are going into the pre-bool particle group. So what we do here is, here we turn the sphere, and it might be a good idea to just rename this as well. Sphere volume. So our sphere volume is calling the, let's rename that, cylinder volume. It's calling the cylinder volumes, and in our particle group of the cylinders we have 3 cylinders, you remember. So that means our sphere is created, we have the volume of the sphere. Now this is activated, and this is activated 3 times. So this activates the Boolean operator 3 times. So it asks 3 times, hey, give me the sphere, give me a sphere. So it will do the Boolean operations, and we see the difference. So this is what we are getting here right now. So we have these 3 cylinders. They are now doing the Boolean operation, the difference. So we are cutting out the cylinders from our sphere. There's an optional thing I put in there between the final set grid stage. That's the beauty we have now with OpenVDB. The distance field is created from this Boolean operator, but the distance field is just floating right now in memory or space, so to say. So it's not committed right now. So we can still work on the result of the Boolean VDB, the output of the Boolean VDB, and we can use this newly created distance field that isn't set in stone right now, and we can work on it with a filter VDB. And now we can apply filters. Right now I don't have a filter applied, it's none, but we can, for example, apply a Gaussian filter, a Gauss filter, and let me just go back and forth, and then you see the filter smoothes, rounds off everything. So the Gaussian filter is a very strong, powerful smoothing operation on our volume data. So we can smooth out really strong the result. And that's the beauty of OpenVDB. Once you have all the volume data, you can modify, tweak this volume data. And just by putting in a filter. There's many more operators. You can do many more things with volumes, and I will come to it later in another session. We can do very complex modifications to volumes. So, but for now, I like the none. So I just wanted to show you that if you want it, you can take the result of the volume operation, feed it into another operator and work with that. So the final step is always to get the actual modifications you do to the volume to write it back. Now I want the final result of my Boolean operations. I would use a SetGridVDB. VDB. So this SetGridVDB writes back the information, the final information into the field. So that commits, so to say, the Boolean operation. And we are also doing here one interesting thing. We are writing the field into the distance and into the restore. So as you might remember, I created in my container the possibility of two volumes, one called distance and another one restore. And in the restore, I want to keep my original volume. So what I'm doing is I'm creating a copy, so to say, of my original volume. So what I'm outputting here, the distance field of this Boolean operation, if it's filtered or not, doesn't matter right now, we can adjust it anytime, but the output here is copied into the restore and in the distance. And I will explain later why we want that and what advantage this gives to us. So right now you saw that we have our first Boolean operation going. So what we get as a result is our sphere and the cylinder Boolean operations. The next thing is another shape to volume that's just sitting or floating there. And this shape to volume, let's have a look, is the operand. And the operand is the torus. If you remember, let me just go back. The torus, oh, I have a typo here. It doesn't matter. The torus is going into the operand particle group. So we're turning the torus into a volume as well, because later we want to do something with the torus. You remember, we want to move the torus through the sphere and do the Boolean operations while we move it through the sphere. So now we have all we need for our scene setup. We have created our first Boolean operation, so we cut out the cylinders right away. What we could have done is do all the time the Boolean operations, but that would be overkill. That's also the beauty of thinking particles. You have full control what you want to do right now, what you want to simulate all over again, or what you want to store. And that's exactly what we're doing here. So in this case, we are keeping a copy of our original result and putting the final result of the three Booleans in here. So we can work now with this object instead of doing all the time, every time, the same Boolean operations. So now here we have another interesting thing where we have a getGrid and setGrid. Why would we have a setGrid and getGrid here? The getGrid operator just grabs an existing grid and we can do something with it. It outputs the field. And you can see here it's the restore. So we are getting our restore. Remember up here we created a copy of our Boolean operation in the restore as well. So we are taking the restore and we are writing it back to the distance with a set grid. So we are writing it back to distance. So what it does is it restores our original object. And it does it all the time. So this restores our original object. And that's why when we have the animation going, our torus going through, it cuts through, it does the Boolean operation, but it heals or repairs the Boolean operation after it's gone or after it's moving through. If I don't want this effect, I can just disable the setup. And now we can have a look how this looks like now. So now I'm creating like a cutting, like a knife, I'm cutting through an object. So now the cut stays there and is permanent because we are not restoring the original object. So now I cut through, I have an animated cut, for example. And if I restore the object with every new simulation step, I'm restoring the original with every new simulation step. We get back to our original and repair it, and then the Boolean operation is done again, and we do the cut. So this is a very simple and straightforward and powerful feature we have here in Thinking Particles. And then we have a show VDB, and the show VDB is just responsible for visualizing the volume of our torus or cylinder here. Torus we have here. One important thing is, why does it work? Because if we restore every time the original object, how does it know when to use the restore thing? And why doesn't it restore while we create the Boolean operation and all this? And here comes the importance of and the power of Thinking Particles into play. The order in our dynamic set tree plays an important role. It's not only with OpenVDB. So the order of the operators is very important. And when you go through this, we have the order, the sphere volume is our first initiator. So it doesn't matter if I put that up or down, but this order is important. So we have the sphere volume and then the rest is all called automatically. Then we have our cylinder volume, then we have our shape2 volume for the torus operator, and after that we do the filter operations, but these are called from this initiator, so we don't care about that. And the same for the SetGrid operator here, that doesn't play a role. However, now it becomes important that our getGrid and SetGrid here, this combination, that this is after everything we've done above. So this is, first we do the Boolean operation, and then we restore the object. So Boolean operation, restore. And this is exactly the order how it's done. So the order in here controls how we do our Boolean operations. What is done first, second, third, and so on. Okay, so let's have a look at our final dynamic set, the actual Boolean dynamic set that cuts out the torus while it moves through the sphere. And that's another pretty straightforward and simple setup. We use our getGrid. You remember, the getGrid just grabs an existing from the container, a volume grid, and then we can modify this data. So what we are doing is we are getting the distance field. So that's the original distance field. And we are getting this from the target. So that's our sphere. So this is the sphere volume field. So let me just sphere volume, rename that so that we know. This is our sphere volume data, and here we're getting our operand. So let me just rename that to torus volume data. That's our torus volume data. And here's the same thing. We have two initiators, and usually you can't have two initiators in parallel, so you have to call each other. So what we are doing is we are using our sphere, and our sphere is calling or activating the torus volume, and then we get at the same time for our Boolean operation, which is also a difference between the difference between field A and field B. So this is our sphere field, and here we get our torus field. We create the Boolean operation, and then we set the Boolean operation so that we actually get the final result in the volume written back. And the only thing left to do, and here the order is also very important, the only thing left to do is our volume to shape. That's responsible for displaying the final result of all the Boolean operations. That turns our volume back into a mesh. This volume to shape is turning our volume data into a mesh data, and we are using the target, that's our sphere, with all the Boolean operations we did, and we're turning this back into a mesh with all the settings we have here. If I were to change now the position of the volume to shape, because that should be your last thing, because at the end you want to turn everything, all your volume operations back into a mesh so that you can visualize it or have it as a mesh in your simulation. So if I were to move that up, you can get funny results, because now all the operation we do afterwards is somehow lost. And you can see that we don't get any interaction with the torus. So no Boolean operation with the torus. So keep that in mind. The order is very important. The order of your operators is very important. So I just moved the volume to shape to the beginning of this. So all these things are happening after I already turned it into a mesh. So I will never see what this does. So I move that down, down, down to the very end of my tree, and then this this will be called at the very end. So we are back, and as you can see now, it's working again. We can cut through our object. And that's about it. That's OpenVDB in thinkingParticles doing Boolean operations. You can do much more stuff with Boolean operations, much more fun with Boolean operations. And I will do some more live streams and things. So let me just summarize what we just did here and what we learned. So the first thing we did here is we bring in all the meshes from 3D Studio Max. We do that with an object to particle. We bring in the sphere, we bring in the cylinder, we bring in the torus. The next step is we use these meshes, but before we can use them in OpenVDB, we have to declare, okay, I want to create a distance field, I want to create a restore field. I explained the restore field I keep as a copy from our original object, so I can restore my original result. And then we have to turn our sphere into a volume. That's our shape to volume. And then we have to turn our cylinders into volumes. And then we feed the fields, the volumes, into our Boolean operation. And then the output of the Boolean operation is another distance field, the final result. And then we can filter it, do whatever we want in OpenVDB. So it's just working on 3D volume data. It's not a mesh or anything. It's working on true volume data. And then when I'm done with my volume modifications or volume data modifications, I store it or commit the modifications with a SetGrid. And here we make sure we keep the copy. And then with the get grid, that's the little trick we use here. We get our original, store it back into the distance field so that we can start over with the original, so with the booled out result. And then we can start over while we move our torus through the sphere. And the order is very important, so we do that after we did everything here, so we have access to a restore and can restore the object. And that's the order in our dynamic set tree. And then The last thing we did is getting the sphere with the cutout of the cylinders, getting the torus, do the Boolean result between torus and sphere, and commit the changes, cut it, and then visualize it with the volume to ship. So that's the whole setup we did here. I hope you enjoyed this little stream, and as I said, we will output many more streams with more and more details, and we are getting higher and higher with our visual effects level here, so that you can step by step learn and understand how OpenVDB works. And I will repeat many times what operator does and why you need an OpenVDB and that it's a container and all this. So you will also learn along and understand what you can do. Thank you for joining the stream, and I'm going to close the stream now. Thanks so much.